We've talked about three types of linear equations. The first type is slope-intercept form, and that is y equals mx plus b. So slope-intercept because you can see the slope and you can see the intercept. And slope-intercept is an awesome form of the equation because you can plug that into calculators like your TI Inspire. Alright, so another form that we've talked about is point slope form, and that's where we have y minus y1 equals m times x minus x1. It's called point slope form because in this one you have the slope and you have a point x1, y1. Remember, we always write them opposite when we write point slope form. And then the third type of equation we have is standard form, and that's where we have ax plus by equals c. And this one's handy because we can find the x and y intercepts really easily. However, sometimes, like I mentioned earlier, slope-intercept is the best form because you can graph it using a lot of technology things, so like online calculators or your TI Inspire calculator. A lot of different things. So I'm just going to go through a bunch of examples of converting to slope-intercept form. So our goal today is going to be getting this form, y equals mx plus b. So here we have an equation in standard form. And remember, our goal is to get it into slope-intercept form. So what I usually do is at the top of my equation, I write my goal. My goal is slope-intercept form. So there it is, y equals mx plus b. Now that I have it written like this way, it helps me a little bit because I can refer to it and say, okay, what is it I really want to have? I'm going to draw my equal sign through both of them because that emphasizes even more. All I want is y on the left-hand side. If we look at the left-hand side right now, there's a ton of stuff going on. The first thing I notice that's really, really out of place is that 2x. So I'm going to subtract that 2x. I'm getting rid of it. Remember, this is an equation, so we have to keep it balanced, so we need to subtract 2x from the other side as well. Alright, 2x minus 2x is nothing, and so we're left with 5y equals negative 2x plus 20. Now the reason I'm writing it like that is because that's the form I want to have in the beginning. I want the x to happen there. That's what slope-intercept form looks like. Alright, so now we look at our left-hand side again. Look back at your goal. What is your goal? Your goal is to have y equals, and right now I have 5y equals. So we need to get rid of that 5. That's 5 times y, so we need to do the opposite, which is divide. So I'm going to divide both sides by 5. 5 over 5 is 1, and we're left with y equals negative 2 over 5. Doesn't simplify, so it stays negative 2 over 5 x plus 20 over 5. 20 divided by 5 is 4. So there we have our slope-intercept form of our equation. Now, if we wanted to, we could actually find the slope and the y-intercept. The slope is negative 2 fifths. I swear that's a 2. And the y-intercept is the point 0, 4. Alright, so here we have an equation and it's in point slope form. So from point slope form we could figure out that the slope is negative 2 and the point that it goes through is 1, negative 3. Which is all fine and good, but it doesn't really help me if I need to use a calculator, so I want to get it into slope-intercept form. I didn't leave enough room at the top, so I'm going to go ahead and write slope-intercept form at the bottom, just so I have that hint there, the reminder. My goal is to have y equals mx plus b. So, I'm going to draw my line, and I'm going to analyze my equation. I need y by itself on one side, and I have a plus 3, so that's not right. Also, if we look on the right-hand side, there's parentheses. Think about the slope-intercept form that we have written at the bottom. Are there parentheses in that? Nope. You got to get rid of those parentheses. And if we remember from solving equations, to do that, we distribute. I'm going to do that step first. So, y plus 3 I'm going to keep the same for a minute. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So, it's getting closer to slope-intercept form, but we still have that pesky little plus 3. So, again, I'm going to move that minus 3. Now, I'm going to put that on the other side underneath the 2. Why do you suppose I'm putting it with the 2? It's because 3 and 2, those are like terms. They're both just numbers, so I can combine them. I'm going to cancel those out because they make 0. And we're left with y equals negative 2x. 2 minus 3 is negative 1. So there we have our slope-intercept form. And if pressed, we could say exactly what the slope and the y-intercept were. The slope is negative 2, which is exactly the same as it was in point-slope form. And the y-intercept is the point 0, negative 1. Alright, so we've seen an example of converting from standard form. We've seen an example from converting from point-slope form. We're going to look at another couple examples of each type just so we can practice our skills. It'd be a good idea for you to pause once you see each problem, try it on your own, and then continue the video while watching me. Alright, so we're in standard form. I didn't do this with the first one, but let's just review. What can we find from standard form? The X and Y-intercept methods. The X and Y-intercepts. So from here, if we were to use our cover-up method, which you can't see as I'm doing a video, negative 5x equals 10, divide both sides, I would have negative 2, 0 as my x-intercept. And as my y-intercept, we would have just 10, 0, 10. Which is all great, but if we're trying to put this into a graphing calculator, we need slope-intercept form. So again, at the top, because I have room this time, I'm going to write what slope-intercept form really looks like. That way I can remember what my goal is. My goal is to get y equals mx plus b. Right now, again, I have that minus 5x. It's big and clunky and out there. It shouldn't be there. I'm going to move that. The opposite of minus 5x is adding 5x, so that's what we can do to cancel it out. Since it's an equation, we're going to add 5x to the other side as well. So, that goes away. 5x plus 5x, or negative 5x plus 5x. We're left with y equals 5x plus 10, because that's positive 10. So, check it out. Yay! We're already in slope-intercept form. And the slope of this line is 5. The y-intercept is a point 0, 10. Which is quite convenient because that's what we got when it was in standard form. Alright, another point slope problem. For review, let's again write what's the slope of this problem? 1/2. And the the point in this problem, the point is negative 12 and 2. So, I'm going to draw my solving line, and again, because I ran out of room at the bottom of my solving line, I'm going to write my goal, y equals mx plus b. So, we want to get y by itself, and we do not want any parentheses. Point slope form always has these parentheses in it, so we're going to go ahead and try to get rid of those first by distributing. Because it's a fraction doesn't mean it can't be distributed. 1/2 times x is just 1/2 x. 1/2 times 12 is 6. Half of 12 is 6. On the other side, we still have y minus 2. Alright, so now we have sort of looking like mx plus b, but we still have a number over with y, so I'm going to move that. I'm going to move it to the other side. I'm going to add 2. Now, look at, you have 1/2 x and you have 6. 6 is just a number, just like 2. So I'm going to add the 2 to the 6. So this way I can cancel those and we get y equals 1/2 x. 6 plus 2 is plus 8. So there's our slope-intercept form. And again, the slope on this one is 1/2. Oh, I forgot to change to green. And the y-intercept on this one is the point 0.08. The slope matches just like it did when it was in point slope form. Alright, another standard form. You see my little pattern? Let's think about what we can find from standard form. We can get the X and Y-intercepts using the cover-up method, which again, you can't see in the video, but we already did that together. The X-intercept, we're going to look at 9x equals 12, divide both sides, and 12 over 9, 4 over 3, our X-intercept is 4/3, which is totally okay. Y-intercept, negative y equals 12, and so we're going to have y is negative 12. I always like to find this first because it helps me check my answer once I get it into slope-intercept form. So I'm going to draw my line, and because of my lack of space, I'm going to write my equation at the bottom, my goal, y equals mx plus b. And no parentheses to get rid of on this one, but we do have that silly little 9x over there, so we need to move him. I'm going to subtract 9x from both sides. Our goal is to get mx plus b form, so again, when I rewrite the right-hand side, I'm going to write negative 9x plus 12. The left-hand side is negative y. Do not let yourself be fooled. You are not done with that left-hand side. There is that negative sign there. Remember, that means times negative 1. This is negative 1 times y, and the opposite of times is divide. So we're going to divide both sides by negative 1. So y equals negative 9 over negative 1 is positive 9. Positive 12 over negative 1 is negative 12. And there we have our slope-intercept form. Now let's check. Our slope from this one is 9, and our y-intercept is the point 0, negative 12. Just like we got from standard form, so this is a good thing. This means we probably didn't make any mistakes. Okay, trick problem. What form is this one in? It's actually in point-slope form. It just looks a little bit different. Y minus 0 equals negative 7 times x minus 1. That's the exact same equation. So we know that this equation has a slope of negative 7, and it goes through the point 1, 0. Now, this one doesn't seem that bad to have to solve, because remember what our goal is. Y equals mx plus b. And this equation already has y equals. The only thing that's wrong are those parentheses. So, remembering from me solving equations, all we need to do is distribute, and we get y equals negative 7x plus 7. So, we can find our slope and our y-intercept now. M equals negative 7. The y-intercept, b, is the point 0, 7. Another trick question, what form is this one in? Point slope again. Just like before when we could do y minus 0, we can do the same thing with our x. So in this case, from point slope form, we can see that the slope is 3, and the point that it goes through is 0, negative 2, because that's just x minus 0. However, if we saw something like this and we didn't like it, we weren't sure what was going on, and we wanted to use a calculator, we could certainly get our trusty slope-intercept form out and convert. Y plus 2 equals 3x. No parentheses. The only thing that's wrong is that plus 2. Subtract 2 from both sides. So, cancel. We get y equals 3x minus 2. Slope in this case is 3, which matches. The y-intercept in this case is 0, negative 2, and hey, look at that point that you said the graph went through from point-slope form. They happen to be exactly the same. Good thing. Alright, back to that other form. Remember what this form is? This is standard form. From standard form, we can find the x and y-intercepts. We use the cover-up method. So, x equals 6. X-intercept's pretty easy. It's just 6. Negative y equals 6, so the y-intercept is negative 6. I'm going to draw my line. I'm going to write my goal at the bottom. And I'm going to look. What's wrong? What is not where I need it to be? First thing that seems obvious to me is the x. So I'm going to subtract x from both sides. Subtracting 1x, really. So, cancel, and we get negative y equals negative x plus 6. Uh-oh, negative y. We don't want that. We want regular y, positive y. Remember, that's negative 1 times y. Divide both sides by negative 1. We get y equals negative x over negative 1. Negative over negative is a positive, so it's just positive x. And positive 6 over negative 1 is negative 6. So we have slope-intercept form. And we can write down that our slope is, oh, what's in front of that 1? X. I gave it away. Sorry. It's a 1, so the slope is 1. What is the y-intercept in this case? 0, negative 6. Which, just to double check, does it match our standard form? Yep. Alright, last converting problem. I decided I'm going to use some cool colors on this one instead of red and blue. So, let's think about what form do we have here? Point-slope form. So, from point-slope form, we can find the slope, which is negative 2, and the point that it goes through, which is negative 2 and 4, always opposites. Now, our goal in this problem is to get y equals mx plus b, to get slope-intercept form. Draw my line, and I'm going to think, what is wrong in this equation? What is not working for my goal? Minus 4 and those parentheses. I like to get rid of the parentheses first, so I'm going to go ahead and distribute those. We get negative 2x and negative 2 times positive 2, which is negative 4. So now our equation reads y minus 4 equals negative 2x minus 4. Alright, so now we need to think what's not towards our goal. Now it's that minus 4. So I'm going to add 4 to both sides. That's a number, so I'm going to put it with the other number. Y equals negative 2x. Negative 4 plus 4 is nothing. So our equation would be y equals negative 2x plus 0. But we really don't need to write it that way. We can write y equals negative 2x and be done with that. So that is our slope-intercept form of our equation. Now if we write out what our slope is, it's negative 2, which it should be because that's what we got in point-slope form. And our y-intercept is the point 0, 0. That means it goes through the origin. So these were just a ton of examples of converting to slope-intercept form, which is really handy when you're wanting to use technology to graph your linear functions. Our three forms were slope-intercept, point-slope, and standard form. All of them have their uses, but slope-intercept is usually the one that you're going to need to use if you're using your Inspire or one of the online graphing tools.